Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss about manufacturing creation because it is part of industrial engineering subject. So I have to explain about this, and it's important for you who want to know about the manufacturing creation and its properties. And it's about all of the operation and others. So we have to start from the manufacturing definition. Manufacturing definition can be defined as the application of physical and or chemical process to alter the geometric properties and or appearance of the given starting material to make parts of product. Okay, that is the basic. It is the basic definition of manufacturing. But here we have the alternative. I have the alternative definition where we can define the manufacturing based on this one and these two kind of alternative manufacturing. The first, we can define it as a technological process. You can say that the process that accompanies manufacturing involves a combination of machineries, this one, and tools, power, labor, and manual labor also, and then we can get a completed part or product. So it is the definition of manufacturing based on the technological process perspective. And the second one here you have from the economy perspective. So what economic viewpoint? From the viewpoint of economy, manufacturing is concerned with the transformation of materials into items of greater value by means of one of all more processing and or assembly the material. So we can say that the key point here is the added value or a value added to the material by changing its shape or properties or by combining it with the other materials that also have been altered. So we can give the example here when sand is transformed into glass, so it has the value added, or when petroleum is refined into plastic, it also has the value added. And also when the plastic is molded into complex geometry of for example, for the passenger chair, it's made even more value added. So economic point of view talk about the value added. And then we are moving to the manufacturing industries. In the three major manufacturing industries, we divide into three major. The first is primary industries, and second one is secondary industries, and the last one is the tertiary industries. What is this? Primary industries, we can say the primary industries that the industries that cultivate and exploit natural resources directly. You can take the example, agriculture. Or other is mining. Or what is that? Petrol. Why it's included as a part of primary industries? Because it's consume and exploit or cultivate the natural resources directly. So it's included as a primary industry. And the second one is secondary industry. Secondary industry, that industry will convert the output of the primary industry and convert it to a product. So the output of this industry become the input of the secondary industry. So we can take the example here. Maybe aerospace, automotive, There's also textile, apparel. It's several examples of secondary industries. And the third one, tertiary industries. Tertiary industries is constituted with the service sector of the economy. So if we talk about the service sector, the kind of service sector industries, can give the example is in bank or banking. What others? Education? Oh yeah, include education. Students? Yes, students. Yeah, I mean maybe insurance, hotels, and other examples. But our focus is in the secondary industries. Why we focus in the secondary industry is the middle industry between the primary and the tertiary industries, because here we have the manufacturing principal activity category. So the secondary industries, we will focus on the manufacturing because it is take the input of primary and we use the manufacturing operation to be a part of product, and then we will focus there. Okay, continue to the next. It's about the production operation in process industries and discrete product industries. So majorly we are only have to know about the production operation. Production operation in what? In process industries and discrete product industries. So we divide it into part. The first is continuous production. What is continuous production? The meaning of continuous production actually is the production. The process is carried out in a continuous stream of material. So there are, you can see that it is continuous stream, Okay, also here is continuous stream. There are no interruption in the output flow. So that is the difference with this one. The batch interaction, they have many interruptions here. This one, they have many interruption. So in the continuous production, we don't have any interruption. So not all of industries can classify this in continuous production. And even in a continuous production, we have to separate it where the process industries and the discrete industries. It is the process industries, is the process industries, and it is the discrete. So why it have to be continuous production? The continuous production, they will be the continuous production in a continuous stream of material directly, no interruption, and it can take examples such as a liquid, gas, powder, or similar material that need a physical state. And then the second one is discrete. The discrete industries in a continuous productions mean that 100% dedication of the production equipment to the part or product with no breaks. But the input is in discrete, but there are no breaks. They still continuous. So there are no break at all for the product change over. Okay, so the second one will see the batch production. The batch production is only occurs when the materials are processed in finite amount or quantities. So the finite amount or quantities of material is called a batch. So that's the term of batch, referred to the finite amount or quantities of materials. So in both process. And batch production is continuous. Why? It is the continuous production and it is for the process also it's same like this. The previous is the process and it's the discrete. Why it is discontinuous? Why it is different? It's continuous and it is discontinuous because the material of this one is in a form of a liquid or gas, powder or similar physical state, so it's difficult to separate that material. But here in the batch production we have it is discontinuous because the nature of the process requires that only a finite amount of material that can be accommodated at one time. So they have the finite material, the finite amount of material that can be processed in one time. So maybe they have the process here to fulfill the limit, to meet the limit and meet the limit, so it can move to the next process. It's only to simplify the definition based on our reference. And we can understand and can separate the differences between the continuous production and the batch production, and then we will move to the manufactured products. Manufactured product, majorly we will separate it into parts to the major classes. The first is the consumer goods. What does it mean, the consumer goods? That's the product purchased directly by the consumers. For example, that's televisions, toys, you can say car or automotive, and other product that can directly purchased by customer, and they can use the product directly to utilize the need. And then the capital good here. Capital good is referred to the product purchased by other company to purchase goods and supply services. So the product purchased by other companies. Okay, we can give the example here. The example of a capital good include the manufacturing of computers, maybe machine tools, just machine tools, because they purchased the machine tools to produce a product, and maybe the construction machineries, and another product they cannot be purchased directly by the consumer. So in addition to the final product, which are usually assembled, there are companies in industrial businesses primarily to produce material, component and supplies for the companies that make the final product. So that's the two major categories or classes of manufactured product. Next, we want to know the simple term of each termination. We'll talk about the manufacturing operation, the processing and assembly operation, because actually we have four kind of manufacturing operation, and the first one is the processing and assembly operation. It is the manufacturing process. What is the manufacturing process? The manufacturing process is divided into two classes. The first is a processing operation, and the second one is assembly operation. A processing operation is referred to when you want to transform a work material from one state of completion to a more advanced state that is closer to the final desired path or products. So it adds value by changing the geometric properties or appearance of the starting material. So yeah, generally we can say that the processing operations are performed on the scribble part, but some processing operations are also applicable to assembled item, for example, such as a painting or welding. That is the difference of the processing operation. So it's move the material to be the part or product. And second is assembly operation. Assembly operation refer to join two or more components to create a new entity, which called an assembly, sub-assembly, or some other term that refer to the specific joining process. And we have some process of the processing operation and assembly operation. Processing operation actually it used many energy. It's very energy consuming. It's one of the highest consuming of energy is in a processing operation because we use we need a huge energy to alter works part space, such as physical properties or appearance, to add value to the material. And yeah, the form of energy include mechanical, thermal, electrical, and chemical. So its energy will use for alter the product from its material to be the part of our product. But sometimes we can see that more than one processing operation is usually required to transform the starting material into a final form. So it's not only maybe a part or a product, it's not only use one of this processing material, not only shaping process, but it use the shaping process, the property enhancing, and also the surface processing. Is why it is very energy consuming. Okay, we will start from this one, solidification process. What is that? The solidification process, it is a very important process in this category, and most of them is we talk about a casting for metal, right? Or mold for plastic or glazes. So we will the term here is referred to metal casting process, in which melted or put in mold and then removed. So that is the solidification process. And here the solidification process can get the starting material is heated liquid or semi-fluid, and it can be poured or otherwise forced to flow into a mold cavity while it cools and solidifies, taking a solid shape that is same as the cavity. So it will be make a geometrical product as we need. And then is a particular processing. Particular processing refer to the starting material when the material is the powder. When the material is the powder, the common technique involved is pressing. So pressing the powder in a die cavity under high pressure to cause the powder to take the shape of the cavity. Yeah. What for? It will increase the strength. The part is then centered, heated to a temperature below the melting point, and then which cause individual particles to bond together. Both metal, just for powder metallurgy, and ceramics or clay products. It can be formed by particular process. And then the third one is the deformation process. So in most cases, for the deformation processes, it's the starting material is a ductile metal that is shaped by applying stress. It is for the ductile metals. by using the stress, giving the stress that exceeds the metal yield strength. So it will be increase the ductility of the metal is often heated prior to forming. So the formation processes including some process such as forging, rolling, or maybe you can say that's bending. It's also bending. And the last one for the shaping process is material removal. Material removal is a solid from which excess material is removed. Remove the material. Remove the material from the workpiece so that the resulting part the desired geometry. We can use several processes such as turning, drilling, milling, and other. Is a very popular technique in the material removal process is grinding, where grinding is another common process in this category, in which an aggressive grinding wheel is used to remove material. Okay, then we go to the property enhancing is a heat treatment. Heat treatment are designed to improve mechanical or physical properties of the work material. The most important properties of enhanced operation involve heat treatment, which includes various temperature induced straining and flattening process for material and glazes. So its function is to improve the physical properties. So if we refer to this one, is a controlled heating and cooling of metal to alter the mechanical properties without changing the shape. So we cannot change the shape because heat treatment, we don't change the shape of the previous product after the material removal. And then the surface processing, cleaning and surface treating. Cleaning and surface. Cleaning includes both chemical and mechanical processes to remove dirt, oil, or other contaminants from the surface. And surface treatment includes mechanical working such as shot peening or sandblasting. And a physical process like diffusion and ion implantation. Okay, that is the example of the cleaning. So for the cleaning, we will remove the unwanted contaminants. Remove unwanted contaminant. And then cutting and deposition. Cutting and deposition, here we talk about applying a coating of material to the exterior surface of the wood part. Common coating process include electroplating, anodizing of aluminum, and organic coating. We can call it as a painting. So the cutting and surface treating, the surface treating here to remove for the coating material to the exterior surface. Coating exterior surface. Okay, that's all the processing operation in manufacturing process, and then we will continue to assembly operation. In assembly operation, we have two major processes that are joining processes and mechanical fastening. What is the joining process? The joining process first is welding. Welding means that joining two or more metal parts by melting both material. Melt both material. Then brazing and soldering. Brazing means joining two pieces of material together with a third molten filler metal. Use the molten filler to join off two the two parts. And soldering here, process of joining two metals by the use of solder alloy. Here using solder alloy. And then the adhesive bonding. Adhesive bonding here, joining two or more solid parts with an adhesive substance. So we use the material, the agent here to help joining two is adhesive substance. And then mechanical fastening. Mechanical fastening means here actually it's the same, but the difference is only here we still be able to disassembly, and here we cannot, is never be disassembly. So when we use the fastener, but after the fastener applied to the product, it still be able to disassembly, and the permanent fastening it never be able to disassembly. So that is the manufacturing processes overview. Okay, then we will see the factory operation. The factory operation. First, okay, actually we have the factory operation. Here we have four. The first is processing assembly that we have discussed before in the previous year. Here it is. And the second one is the factory operations. The factory operation. The other is actually it is now 2, 3, and 4. Material handling and storage. Inspection, testing, and coordination and control. So why material handling is important? So I will give you the reference from the Eugene Merton. Eugene Merton, that is an advocate of spokesman for the machine tool industry for many years, observed that materials in a typical metal machining batch factory or job shop spend more time waiting on or being moved than being processed. So his observation, I have showed his observation here. It is his observation. So we can see moving and waiting, it takes about 95%, while the time on machine of that product is only 5%. And if we focus and analyze it more to this one, that from the 5%, that's only 30% that really in under the machining process, and 70%, well, it's the loading, positioning, and cage. So it is actually 1.5%. They are in the machining process, and he is 3.5% in the loading, positioning, and caging. So why it is very important for us to maintain or to manage the material handling and storage, because it's very, very consuming time, and it's also very related on the consuming of cost, because the time on the production process is very related to the cost of production. So we will discuss about material handling and storage in a later discussion, and it's very important. So we will give many attention in this. And then the inspection and testing. For inspection and testing are quality control activities. Actually, this is the area of the quality control, where the purposes of inspection to determine whether the manufactured product meets the established design standard and specification. So it's we talk about the conformance, but actually we have several from the Vincent Caspers. We have the several items. I forget this, about the 7 or 8 quality dimension for Vincent Caspers, and in inspection we will check the conformance, but the design standard and specification do the product meet the design standard and specification, so we need inspection. But sometimes the quality control process, inspection and testing here, it can be categorized under 3 classes. First, I can say it sometimes is wasteful. If all of things in the factory were about the quality, so we don't need inspection anymore. So it will be wasteful if we still use the inspection and testing in the end of the product. And then the second one is auxiliary. When it will be the auxiliary when the products it is not give the directly value added to the product, but it have to be there. So such as loading, unloading, is not important at all maybe, but it's the auxiliary process. The auxiliary process that it have to be there, so we cannot remove this process. And the third one, I can say that the inspection is value added. It's a value added process when the final inspection is very important, because not all of the person, we can guarantee not all person in our industry that is aware to the quality. So we need a inspection process. But distribution inspection or final inspection, we'll discuss it more about inspection and testing in the later discussion. And the last one is coordination and control. Coordination and control in manufacturing include both the regulation of individual processing and assembly operation and the management of plant level activities. And control here, even the control process level involves the achievement of the certain performance objective by properly manipulating the inputs and other parameters of the process. So control the process level, we also discussed in that later, because it is only the preview, it is the first discussion of the manufacturing operation, so I only give the introduction of each terms. Okay, thank you and bye.